I did share like a small task. Uh, Probably try to do it before this weekend. Uh, I mean, it's part of the same session. We just split into two parts, right? The project and then the database. Actually learning the SQL, MySQL, and the bit of Mongo. So for now, this task doesn't require you to do anything with those. It's just the same REST project, but instead of using a array in your code, you're going to create a db.json file and use the fs module to add create objects from that file. Okay? So just go through this. If you have any doubts, let me know. So let's just get started with today's session. Yeah, so today, it's the second part of the same session. We cover the fundamentals of what is a database, why database management systems are really efficient, why we should use them compared to your local files, right? And today we even saw different types. What is a SQL, no SQL type databases? What is the difference between both? Yeah. So today we'll just take a look at these things. We'll learn a little bit of SQL syntax. Think of SQL is basically just another programming language. Okay. Then using that, you're going to create queries. Queries we learned was basically requests that you put your database to get some data or to update something. Right? So in reference to any DBMS, you call it a query. Then obviously we'll go through these basic actions, creating, deleting, updating, same CRUD thing, but instead of on an API level, it's going to be directly to your database. And then after covering a little bit of SQL, just the basics we'll go through. I will share your resources to go in depth. After that, we'll take a look at MongoDB. There's also something called MQL, but you don't have to go through it because MongoDB already has Atlas and other tools where you don't even have to learn the MQL language. You can directly start interacting with the database. So we'll just take a look at that, a small overview, and then we'll see how it's different from MySQL and how we can actually configure a MongoDB database. If time permits, probably it won't because there are a few concepts. Probably we'll cover this in the next one along with the templating. It's like instead of your db.json in the next one, we'll actually connect the database in your Node.js code and use that to populate your HTML files. We'll probably see that in the next one. Okay. One common thing I noticed, a few of you had doubts, was this. So we've been working with backend for about 4 sessions, right? We saw in a project, we had node modules, index HTML, server.js, package.json file, right? And in the previous task, what was given to you was to send a HTML file from your backend and submit a form. That all was correct, but one mistake many of you did was you linked your server.js file to your index.html. That was a bit of a mistake because your server.js file is a backend code, whereas your index.html is a front-end code. So when you're linking anything, I mean, when you're going to link this to your backend script, it does not make any sense because that's the whole part of front-end backend, right? Front-end is what the user sees, backend is what they don't. So this part I just wanted to emphasize on. So your node modules, server.js, so all these are your backend code. And your public directory and your index.html. Probably one more thing we'll see in the next session is called views. That is all that come under front-end code. Okay. Just wanted you to know this difference. It's like you could say in the same project we have both, but you should know the difference between which file or which directory comes under which section. Okay. Obviously, this is not the only way. It's not necessary to have them both in one code. You can create a separate API project hosted somewhere else, and you can have your old front-end code somewhere else. That's how many apps work like that today. They have a separate front-end and a separate backend. Okay. So for now, what we're doing is we're keeping everything under one hood so that it'll be easier for us to keep track of all the changes that we do. All right. So one common question that I thought some of you might have, when should I use MySQL over MongoDB and vice versa? Okay? So whenever you have like a highly structured data, you know which value will have what data type, you know where everything falls into place. That time you go with SQL type bases. When your data is unstructured and you know it will change over time, or it becomes very nested, in that case, you go with non-relational databases. So some examples you might see with the relational ones are CRMs. The CRMs are basically customer relationship management systems. Then obviously you have your client, employee, student database. Here everything is defined, right? There's not much nesting. Everything has its own place to be at. Then obviously for uh, unstructured and usually nested type data, you have chats and messages and comments. You know how in Twitter or Reddit, you can put a comment and each comment can have a comment. It goes on and on and on, right? So in that case, NoSQL databases are really well because they facilitate write and nesting options at ease, correct? Okay. So something that is kind of important, but we'll use it at a later point, is called object relational mappers. So it's basically a library or a tool that you use to connect your SQL database, and it provides you certain methods, certain functions that you can do directly without having to write raw SQL queries. So just as an example, suppose say we are going to add some data to a table, this is the syntax for it. Okay? We'll take a look at it in a while. Uh, this is how you write a raw SQL query. But instead of doing this, what ORMs facilitate you to do is you can just put user.create and then you pass in the object. Under the hood, it will literally do the same thing. But it's important to know how it actually happens. So knowing this makes this a bit more easier. Okay. Yeah, let's actually get started. I hope everybody has XAMPP installed. Uh, I am in my laptop today, so I have it installed. Let me just install this quickly. Let that download, we'll just continue. Yep. So we downloaded XAMPP because it had a MySQL server that we can use. So before we actually get into XAMPP part, we'll just take a look what MySQL actually is, right? It's an open source relationship database management system. Very big term. I mean, you can just call it OSRDB. It's a bit big, but basically the way SQL works, MySQL works, it's open source code. You can access it in their GitHub organization and see how they actually host it. Obviously uses the MySQL, I mean SQL syntax, the structured query language, but there are some differences. Some data types and some methods, while available in MySQL, may not be available in other relationship databases like Postgres, SQLite, all these. While the language remains the same, SQL, there are some small differences here and there. Okay, but we learn it in terms of MySQL because this is probably the easiest way to pick it up. Okay. Other things with MySQL is it's suitable for both your projects and even for enterprise level applications. Especially we saw, right, read operations are more preferred in MySQL. Obviously has multiple language supports. You have many ORMs. You can even directly write the queries from these languages. JavaScript, Python, PHP being the OG type language that it was already always preferred to use with. It still is, okay, because WordPress uses this as huge. And obviously, it can run cross-platform. It can run in your Windows, it can run your Mac, Linux as well, preferably Linux because that's where you'll host it. So, but for now, like whatever operating system you're using it in, it's totally cool. It works fine. So, MySQL, right, is not something that's to be taken lightly. It's used mainly by WordPress. Even Shopify uses it in the back. If I'm not wrong, Twitter and Airbnb also uses MySQL database. Okay, so what exactly is uh, or how exactly is the data stored in MySQL? It follows a relational model, and we saw that relational model is usually of a table format. So in a table, you obviously have rows and columns, and your columns are basically your fields, and your rows are your entries. Your fields basically you can think of your keys in your objects, like the name, email. These are the common stuff that you have for everyone, right? And then your rows are your entries. So every entry will have a different value. Name can be one, I mean, ID can be one, two, name can be pronunciation. Like this, it can vary for each entry. You can see it's very similar to a CSV file or an Excel file, right? Uh, I mean, you can think of it that way, but but SQL, right? It's even more powerful than your normal spreadsheet. It has much more capabilities and better processing compared to your spreadsheets alone. All right, we'll take you can see in a while why that is now. So as any other language, uh, SQL also has its own data types, right? You have the numeric data type, string and dates. You might have seen it in JavaScript also. You can correlate it to it. But here, we get very close to a hardware level a bit also, because you have numeric in, float, small in, because all of these, they are allotted a specific memory size. And since we're dealing with databases, it's important to know how much each field will occupy specific memory, right? Even when it comes to string, you have varchar, text, car. So all these taken an input of how much bytes to actually take up in your memory, and then it makes sure that whenever you're adding data to your table, all these uh, restrictions are followed. Okay, more like rules, so that you don't go over your memory limit or something. Then you have date time, timestamp. Might look similar, but small differences. Date obviously just shows the date alone. Date time stores the current date and the like hours, minutes, second timestamp specifically for yeah, for your date and time specific to the ISO format, I guess. There are many others. You can check it out in their documentation also. Just go to the official doc. You have like these many types. You can go into detail. Suppose it's string, and you'll get an idea over here. So these are the basic ones you'll work with. The ones I mentioned here. You won't go more than that as you start. So this should be fine for now. Okay. And yeah, so there's two other things that we'll take a look at now, but it won't be in this diagram. We'll do it together. So you have two things called table relations and ER diagrams. ER basically stands for entity relations. It tries to relate how one table relates to another. We'll look at that now. And table relations meaning how is there like one to one, one to many, many to many. This also we'll see in a while. So if you want to follow along, I mean, just take this link over here and yeah, just open it up and do it together. I haven't done anything yet, so I'm just starting a new diagram. Let's try to create a ER diagram for a simple social media. Okay? Media, and just take your database type as MySQL. let this. Okay, let that happen. Okay, so I mean, I'm working in this for the first time. I guess we have a table option. So let's see. In a social media app, you obviously have the users, right? So we can create a users table, and we'll have a ID to differentiate each user. This can be probably, yeah, obviously, and we'll get to look at that in a bit. Okay, this is a good thing. Just simple int is fine, and obviously, okay. So when you're working with tables, you have to define each field before actually being able to insert data into it. Oh yeah, so we have the name field, the email field, all these, right? Obviously the ID field as well, so that each user is unique. And obviously we have something called, when it comes to relational databases, you have something called the primary key and the foreign key. So if you want to take a look, I mean, the easiest way to relate to this is when you go to Instagram, you create a post, right? Now, how does that post know that you created it, right? So that sort of relationship is what we are looking for uh, over here, and we can create that using primary key and foreign key. So come back to the builder. Yeah, so you have your user. We can add another column. Column is basically a field, right? So we'll put a name. This will be a varchar, and yeah, this is fine. Then let's add another one for your email. Email as well can be a varchar. Varchar basically means variable character length. So you can see when I click on it, when I'm typing varchar, it shows something like 255, right? Because generally it's the number of bytes that can be allocated to all the characters that are there. Anything over that is going to take one more additional byte, which is not really required because emails and names don't generally go over that limit. So you can leave it as it is. Every user should have a unique email. So I guess we can set that. I mean, it's not a primary key, but it should be unique to each. Okay, ID, name, email, this should be fine for now. Suppose say we can add a bio also. Bio, we don't know how long it will be. So in this case, you can just go something like text, which will set into uh, any variable length that the user enters. Okay? So this is that. This can be empty as well, so it's not mandatory either. Then we'll obviously have the post table. So every post again will have its ID, which will be a primary key. You'll understand that in a minute. I'll show you how. Then every post will have a title. This will be a shortcut. This can be a limited one. Then every post will have a description. And this can be text because it can be a bit long. And now this is the part that comes. How do you relate one table, one entity to one another? How do I know that this post belongs to this user? That's why the concept of foreign key comes. So you can mention that hey, there'll be a field called user ID. This will be a integer because the data types need to match. Okay? But how do I relate this user ID to the user ID in the post table? I'll just come to this. Okay, I mean, in the code level, we can see it. I guess here it's not that one. But yeah, this is how you generally do it. You link these two. So it creates a, okay, that also shows that. But yeah, so it had an option to link it there. So the user ID in the post table is related to the ID column in the, I mean, the post table to the users table. So it shows that the primary key of one table should be a foreign key in another table in order to get a relationship between them. But now, what sort of relationship it is, right? Maybe we saw the diagram. This is basically an ER diagram, really, right? But then this line over here, what sort of relationship it is? I showed you three things over here: one to one, one to many, and many to many, right? So yeah. So when it comes to users and posts sort of relationship in Instagram, you can see, right? One user, you can put many number of posts, right? Many number of posts, stories, reels, all that. But every story and reel is only belongs to one person. Sure, there's a collaboration option, but forget about that now. But every post only belong that you put is only related back to you. It's not like if I go to my friend's account, that post does not come back to me, right? It just shows that this guy posted that post. It's a very singular relationship from the post side, but from the user side, it's like I can put how many number of posts I want. So in this case, it's a one-to-many relationship. So we can just use this. This should be the other way around. This should relate to this. This is a one-to-many. So you can see this three lines over here that came extra. This is an convention that is generally used to show that, hey, there's this is a relationship that starts at this table, meaning every user can have many posts, but every post there is one line only relates back to that user. So it's a one-to-many relationship in this case. Okay? Okay. So any doubts with this so far? I mean, it might seem a lot, but I recommend that you do play around, make your own ER diagrams, all that to get a hang of it. If you want to learn more about the relationships, try to, see real world examples of how it works. Maybe your generally your CRMs, maybe you might have not used it, but this is the most simple example I could find because everybody uses social media, right? So yeah, any doubts so far? I'll actually start with the SQL part. Okay, so if you've installed XAMPP, just open up the control panel and start the server and MySQL. And let's open it. Just click on admin in the control panel after you start the Apache and MySQL modules. Okay, so let's just get familiar with the basics of what we need to know. So obviously on the right sidebar, you can create various databases. Better not to interact with this. So MySQL, as we saw, it is a uh, database management system. So meaning you can have many databases and under each database, you can have tables. So, and over here, you can just go to databases. It will show you like, hey, the one we saw on the sidebar, the same ones are here. So every database is basically follows a general convention of how to store data, like how in HTML we put, right? Uh, char set equals UTF-8 in the HTML tag so that the conversion of the text is done in the right way. Same way in here also you got to specify the type of character convention. Then you can execute directly SQL queries over here. Right, just click on this, you'll have a text editor and you can add queries over here and then click on go. Right now there's nothing, so it's not going to go. Other than that, you have options to export your database and import databases also. So probably in the next session, what I'll do is I'll write a general query to populate a simple table, and I'll export it. And what you guys have to do is import the database over here. Okay? So to get started, obviously, we need a database first. Don't touch any of these, but we can create our own. So we are creating a social media app, right? So the simple command is create database, and then the name of the database. So here we can put like social media app, something, and just click on go. Okay, so you can see it actually created one here, and yeah, it's there here right now. But suppose say you want to see a list of your database. Usually you won't work in a very friendly environment like this. When you're working in production, you'll probably use your um, yeah, you'll use a remote connection or your terminal of sorts to another's computer, and you won't have a GUI of this. So you have to work with your terminal, but you can pretty much rely on these queries because these remain constant over in every other place that you use it. Okay? So suppose say you don't have a GUI like this, how do I know what are my databases? So you have another command called show databases. Just let me. I have no idea. Okay, that was the right command. Yes. Stop and start. Yeah, so it gave me the list of databases that I have currently in my MySQL DBMS system. The one we created also here. So now after we have all these list of databases, we need to select which database to use. So for that, we just use a command called use, and then the name of the database. So social media So it's not see, it's basically it's an yeah, it's got executed. We are currently using it. So we'll keep that at top. And the next thing you want to do is to be able to enter data. But before that, we need to create those fields, those specific tables that we want to use. So we have the command called create table, and then the name of the table. So we'll keep it as users. And yeah, I mean, you can see the convention that I'm using, right? All caps for SQL keywords, but it's not necessarily true or a compulsion to use this. It's just that it's easier to understand the keywords in SQL compared to your normal text. Otherwise, it gets a bit confusing. So it's a convention to use all caps uppercase for your SQL keywords. So when you're creating table, you need to define the fields. So we had the ID, we had the name, we had the email and the bio, right? After that, we need to assign a data type to each of these fields. So ID, obviously, it is your, it's an integer. It will be a primary key. And we can add something called auto increment. So what this basically means is my ID will be of integer data type. It can go from negative to probably whatever the limit is. Obviously, we need to have a relationship. Every table should have a primary key. Then auto increment as in it will start at 1 and it will keep adding for every new entry. So 1, 2, 3, it will keep going. Then my name will be a varchar of 255. This is going to be not null because we need a name to create an account. Same over here, varchar 255. This also should not be null and should be unique because every user should have a unique email. Then obviously your bio should be a text and this can be empty. So this is a general query I'll be using to create a user table. If we open this up, you can see there's nothing in my social media app database, but let's just execute this. And yeah, it's saying SQL.NET. That's totally good. Let's go to it now. And you can see there's a users table now. I'll open this up. And yeah, right now it's empty because we haven't added anything yet. But yeah, we'll do that in a while. So let's do it now. So SQL. Yeah. So let's to add data to a table, you have a keyword called insert. Insert. Uh, insert into and then the name of the table. So we have the users and then it asks you for the order in which you want to insert. So we had certain columns, right? You can either put it in the same column like we mentioned, I mean order we mentioned here, but we will hardly remember that. So it's better to mention the order you're going to insert in. So I'll just put email, name, and then a bio. And then you want to specify the values that you want to enter. So values, and then you put those values individually. So email, Kunal, email.com, name, Kunal, bio like developer or something like that. Okay. After this, let me execute. So yeah, so it came back successful. Let's go to the query box again. You remember we put email as unique, right? So what if I insert the same value again? Let's try it. This throws an error, duplicate entry for the key email. Really cool, right? Would you be able to get this with Excel or spreadsheet? It would be like you have to write your own function, but this is an inbuilt functionality with SQL. So let's just go take a look at the users table now. And you can see you have the ID one because you put the auto increment and all the other values are already here. Let's try inserting one more data. Insert into users. And for this one, we'll just put the email and name. Let's skip the bio because we didn't put it as not null, so it can be empty as well. So and then the values. In this case, it's going to be gmail.com, then name, and let's run this. Okay, that worked. But now I mentioned you won't always have access to your to a very good GUI like this. You'll mostly work on your terminal, right? So how can I fetch all the data and you view it? So for that, you have something called the select statement. It works like this, select, and then you specify the fields that you want to get from your table. Suppose in this case, I want all my fields. So I'll just put an asterisk and then from, and then you put the table name. So I want it from users, and I'll just execute this. You can see I got these. You can see ID. Okay, this is coming as 3 because in our first attempt, we tried to insert something. The ID came as 2, but then it gave an error. So it moved on to the next part and added as 3 directly. Then the 2 emails. Bio, I didn't put anything, so it came as null. Null basically means it is not there at the moment. What if I just wanted to get the emails for from the table? I'll just come over here, remove the asterisk, I'll just put email. And now we'll have only the email. Okay. You know what, let me just run this for a while. Insert into users email values as I'll just put different emails here and there. Right, so I just added some data into that. Let's do it again. Select all from users. With this, I'll get everything, right? And imagine, obviously, in a real world application, you won't have just this many users. There would be like thousands of users, and getting them in one query is not efficient all the time. We probably want to get them in parts. We want to limit them, uh, limit the number of users you get at a specific time. So for that also we have something called the limit, and you can put a number of uh, records that you'll get in a while. Suppose I just want 3 at a time. I'll execute this. I'll get only 3 from the top, right? So if I wanted 4, I'll just put 4 and it'll get me 4 from the top in the order in which it was entered. Okay. Now, suppose I do want it to be organized in a certain way, maybe by the time it was created, by the date that they joined, by the time that they recently put a post, sort of like that. Or maybe even by the ID. What if I want all the users to have ID greater than 4? So in that case, I can use something called the order by query. So order by, and then you put ID, and then you can basically specify a condition over here. Probably greater than 0. I mean 4. Oh yeah, sorry. It was not this way. Yeah, it's order by ID, and then you specify whether you want it to be ascending or descending. If you want it to be ascending, just put it like this. And if it was descending, you put it DSC. You know, while 0 draw is good. Let's see. Oh, yeah, so it's working in the same way we want it to be ordered by. Okay. It's not necessary you have to put like in this order, you can even specify certain conditions. Suppose say I want it to be in descending order and I want all the IDs to be greater than 4, then in that case you can put an AND condition with an ID greater than 4. If I'm not wrong, this is how we write it. Yeah. Oh, right. Before that, you have to specify a condition. Since we are filtering, I totally forgot about this. We have got to use where. Let's take this out. Yeah. So say I want all the IDs, all the users whose ID is greater than 4, and basically I'm filtering out, right? So use the where condition, and let's run this. It should give me everything greater than 4. Uh, what if I want it less than 6, greater than 4, and less than 6? So in that case, you can put and ID less than 6. So this is basically a strict equality, right? So it should run the value the user with ID 5, and yep, it works as expected. Uh, Now, in most cases, like you've seen how we've limited the number of users we get, arrange them by their ID, even run some filtering conditions. But sometimes you want to do some search operations as well. So let's say I want to find, let's just do a select on from users for now. Yeah, suppose I want to find all the users who have this KK in the email, and anything after that is also valid. Okay, so in that case, I can use something called like operator. Okay, and in here I can specify uh, I guess it was and like, and then you specify how you want to search. So in this case, it's just a KK, and then you put a percentage. In case this means it. Okay, it's that's the second. Should be where, not at. Yeah, this should work. So it should give me like all those KKs which I've added in the email except the one with the full name, right? So see, it works exactly like that. What if I want specifically the ones that have one after it and then anything in the start? So I just come over here, and the percentage sign basically means match anything that is similar. Anything after it is valid. So it creates a pattern of sorts that you can search in your database. Yeah, so that worked too. All right. Good. So these are, the most basic things like adding, inserting values into your table and all that. I will leave you guys to explore the updating data and also deleting data. So you have these two functions called alter and one more called drop. So these things you can take a look at from the documentation as well. They are, the syntax is very similar to what we just saw, right? And the next part basically is when you want to join two tables, right? Let's just create another table called post. So let's see how we can actually relate it. Okay, so create table post, and this will have the values. So ID, this will be in primary key and auto increment, and then you'll have the title, which will be a varchar of 255, description of text, and obviously we need the foreign key, right? So we can add user ID as an integer, but then we need to specify it as a foreign key as well. So so come to the next line, you can put a foreign key, and you specify which value it actually is, user underscore ID. And then you need to tell how, I mean, from where is this foreign key coming from? Which table is it going to reference? So you have the keyword references, and then you put the user's table. I guess this was it. Users. I am making one mistake. Oh, good. So I need the users and the ID over there. That users and then specify. That is not wrong. Yeah, that worked. Let's create the table. Create this thing. Good. This worked. Okay. I mean, syntax wise, it's been a while, but yeah, the table worked. Let's go to it. And you can see all the values over here, right? So let's create some posts as well. So do posts, title and description, right? And yeah, obviously the user ID, which user created it. Values will be the description and description. And let's assume the first user created it, and we'll just run this. And this can run over and over again because one user can have many posts, right? This can, even for the third user, we can add one. And 7. Let's just primarily keep it for the first user so we can use the join queries later. Go to the post table and all that value should be there. So every ID over here is the primary key of the post table, whereas the user ID over here is a foreign key that relates to another user. Okay, you see when I clicked on that, it came over here and it showed me the query as well. Select all from the users table where ID is equal to 1. Cool. So let's take a look at, what if I want to get the post and the users data together in one single query. So basically it's like I'm going to relate two different tables and get all the data. That's how it also works on your Instagram account. When you go to your profile, it gets your post and your profile details also together. So in that case, what I can do is come to my query over here. I have something called join queries. So when you come to this is it. Good. So you have something called your inner join, full outer join, left join, and right outer join. Okay. So I mean, obviously you can go into small depths over here, but forget about the outer part here. Just focus on the left join, right join, inner join. Actually, full outer join is not a function in MySQL. It is part of other database like Postgres though. So we'll try to take a look at these three. Okay. So inner join, what it does is, let's come to the ER diagram. What it does is it gets the common values between both. So in this case, it's probably be the ideal. Those are the common things. So we get that part in one single query. If you want the left side table data alone in relationship to your post, suppose I'm going to go to my user. I want all the user data whose post ID, I mean, who made these posts. So the user ID field and the ID field in the users table should match. It's actually true for both the conditions, but in the left join, it will only get me the data from the users table, whereas in the right join, it will get me the data from the post table. So if I come to my query, let's actually write it out. So select on users. Okay. Then in this case, you can then put inner join with the table name. So in this case, it will be my post. And then you need to specify the condition in which the join should happen. So on users.id is equal to post.user underscore ID. We will run this query. Okay. Oh, okay. It should be just ID. Okay, this is normal as well. Yeah, that worked. Yeah, so inner join got me all the details between both the tables. So join the table, you can see the user ID primary key on the side, then another ID for the post, and all the relationship between both the tables with reference to the foreign key. Then you can obviously do a left join also. So in left join, I told you, it will primarily focus only on the user's data, the data. So you can see, yeah, mainly the data for users is there, but the data for the actual post is not being, it's not visible because we did a left join. Then you can do a right join as well. Yep. Yeah, so any post that was not there for the users, that was ignored. But the post that we created for the users, 1, 3, and 7, right? That is actually there here right now. Okay, so I'd say take a deeper look at this. The joint queries, these are really important when it comes to building apps. And yeah, I'll share you some resources. Just take a look at this. So this was for MySQL part. I guess we are over 1 hour already. Cool. I mean, I'll just give you a quick overview of MongoDB as well. You can go to mongodb.com. Yeah, if you have any doubts, just feel free to unmute and ask right now. And just go ahead and create a account. I mean, if for you might be type I already have created before. Just log in Google. Uh, I mean, thing is, we won't be using MongoDB for a while. It's actually pretty easy to book. I'm thinking maybe we can do MongoDB in the final project that we're using. What do you guys think? I mean, I just wanted to show like it's pretty similar way. You have your database is basically called your top level database is called cluster, and inside clusters you can have multiple databases, and each database has collections. I'll just load a sample data. So work something like this. So you have a database, you have collections. So you can think of in this way, your collections are basically your tables in your NoSQL type database. And inside each collection, you have a document. So you have a users collection. And inside each collection, you have documents. These are 1, 2, 3, post 1, 2, 3. So that is like a difference of how you actually reference it compared to Mongo and MySQL. You have rows for each entry. In this case, it's just a document for each entry. Okay, this might take some time to show you. Yeah. Yeah, cool. So this was my social sphere project. So let's take a look at the users one. Yeah, so this is my collection. Basically, social sphere is my database. I can have many database in a cluster in MongoDB, and each database is specific to a project, right? So in that project, I can have users, and the links are basically the links that they create. So here is my user collection, and inside these, I have my documents like these. So it's very like an object way to see your NoSQL type database. Whereas in your SQL, you see it in form of tables. This is like an object overview. difference over here and how you see it in the MySQL. It's very clear, right? It's here you see it as a table format. Like here it's as a table. Okay. Usually I was going to show you like how to download the Compass, but it's okay. We can skip that for now. We'll not be using it for a while. It's basically a GUI like your PHP MyAdmin to interact with your MongoDB Atlas database uh, without having to access the browser. Over here, you have the admin panel that opens it up. In the Compass, it's like a desktop application that you can use to access this cluster. Correct. So, yeah, I mean, that was it. If you guys have any doubts, just let me know. And I will share the resources and the code. I mean, not much code, but from the previous session's code, I'll show you. It's there in the repo. So, yeah, that was it. Just let me know if you have any doubts. The code is updated in the repository. Okay, all the code is. Cool. I mean, yeah, if you don't have any doubts, you can feel free to drop off. If you have any doubts, just unmute or put in the chat box. Thanks for coming, guys.
Thank you, Raya.
Thanks, guys. I hope that it will be good.